We're bringing on Julia here from Multion. Julia has a background working on researching user-based scale satisfaction metrics and methods for the last 15 years, dating to web search scenarios, and spent 6 years conducting research on agent-related concepts at Microsoft, and now works building agents at Multion. Who has a tagline of building agents that complete tasks start to end. So I'm very curious to see what Julia has to share with us. With that, I'll let you take it away, and I'll come back in for Q&A at the end.
Thank you so much for the introduction. I'm happy to be here and share some of my work on agent evaluations. So, and just to highlight what you will get out of this talk today. So if you're interested to build LLM-powered applications, was basically like in agentic space, and you're building it for various domains, so you want to understand what potential metrics you need to optimize your application for. And sometimes it's actually a lot of work to figure out what needs to be done. For example, like if you look at a great example of such an application, such a web search, has been a lot of work and research done by a huge community to even figure out what's kind of a right metric to optimize for from the user perspectives, because in the end of the day, we're all building those type of things for the users. And I was lucky to be part of AutoGen. So it's probably if you looked at an agentic space, probably heard about this open source programming framework, which has been released in September of the last year. And I think it was one of the best and attracted a lot of attention. So, and I was just blown away by the idea how many people are trying to use the agents, LLM-powered agents, to solve all kind of tasks. All kind of tasks. You could see, like, especially like on the Discord community, we could see like people were using it to build like teachers, to build analysts and things like that. But the difficult part in machine learning is actually figuring out what's your objectives, what basically you kind of build in, what you want to optimize for, and what you want to design as a metric. So it's relatively easy if you think about such tasks, like, for example, as object recognitions, because you can just get the ground truths and label that and just focus on making sure that your algorithm is working well. But if you're building something for the end user, you need to care about how your end users are satisfied or not satisfied with an experience, and what your application is even done for. And so kind of the motivation to get into this idea of kind of scalable approach for evaluating agent performance, or like not even evaluating, but even understanding what kind of utility it may or may not bring to the users. So we decided to start to explore this, because we have seen how many different types of developers all over the world start building the applications for the users, and they have to have a tools to figure out if the applications, if the agents they're building are actually achieving the needs user actually kind of highlighted. And so again, most of the time, this type of things done in like in machine learning settings, when you have sort of ground truths, you collected, you labeled, but it's not always possible, especially with such a rapid way of technology. And even like, again, for that, you need to at least understand what's your objectives. So, and there's also a lot of research has been done already to show that LLM itself can be efficient alternative to get an idea about what your users actually want, and help you to evaluate the systems you're building, and you need to do it fast, and it's a relatively cost-efficient way of doing this. So I will not go deep into this because it's not part of the talk, but if you're interested, like, you can write a lot of papers where you could maybe highlight this LLM as a judge. So, and this process needs to be automated. And especially it's important for the tasks when you sometimes don't have any ground truths, and you want to figure out this by going through your data. So, and we basically, another important aspect why we really wanted to bring AgentEval out there is like also empowering the developers and make them aware what potential utility of the applications they're designing can bring to the end users, and make them aware about that and hopefully care, so that while they will be improving and changing the agentic system behind it, so they actually know they're not acting in the dark, but they have a tool to figure out if it's getting better or worse. So if you let me be a bit more structured on this aspect, it's like, so we have seen a lot of tasks which is users trying to solve using the LLM or LLM-powered applications. And there are tasks where success is not clearly defined, because success is usually for us as machine learning researchers, it's something like great if it's on a binary scale. So if we have completed the task or not completed the task. So, but for example, if you see the assistant is writing email for you, and then you kind of copy this email and change it here and there. So like, what exactly was the success here? So that's still on like interesting direction for the research. But there are tasks where success are clearly defined. For example, if the goal of your like LLM powered application is to solve the math problem, so like one of those benchmarks we all care about, so like the success is clearly defined. So because we have a ground truth, we know the right answer, and we can judge if the solution was correct or not. So another aspect of those tasks is that when you do have a kind of preferred optimal solution for this, and there are some cases where there's multiple solutions which lead to the same sometimes incorrect answer, and you would need to figure it out which one is actually better for you or not. So why I'm bringing up that here, because what we're going to discuss next is a new way of defining what's utility the LLM-powered application can bring to the end users, and we try to be as domain agnostic as possible. So meaning we cannot really provide it with a concrete benchmark, and so the whole idea about benchmarks at the moment is probably also needs to be discussed in a separate talk. So, but while we're building this approach, we want to kind of show that it makes sense. So we need to kind of start somewhere. So, and we decided, so obviously that's going to be much easier to start with the tasks where success is clearly defined, and see what we can do for this type of tasks in this space. And so for this particular presentation, I will be using the task as solving the mathematical problems as one of those, so which is clearly defined. And so like we tried AgentEval on various types of tasks, even not where the success was defined afterwards. So like you can look up this in the paper or online. So first, we need to reconsider the idea that you need to define the utility, because you're not building the application just for the application. You want to help users to solve some particular tasks. So, and usually, so you have those criteria in mind, like that's you building the solution which is doing something faster than another solution, or it's kind of less or more effort. So, but there might be something which you cannot really even look at the moment. So, and usually when you do that for the new tasks, like for example, how to evaluate the teacher performance, you have to define a lot of criteria, and it usually takes used to take a lot of effort and a lot of ongoing user research and so on and so forth. So what we're going here is that like most of the developers do not have this type of support, time, or even kind of proper education to do those user research. So can we define the critic agent, which will help the developers with defining the criteria, which the application is needs to be kind of evaluated, and that's basically those criteria express some kind of utility to the end user. And the quantifier agents can assess how well your particular solution is doing according to defined criteria. So we're basically trying to define kind of multidimensional task utility. And just to give you like a thing out of scope, so I picked the math example for the reasons that I think we all probably a bit domain expert in math here, because we all studied it at school and maybe at some other levels. So basically here you see the criteria for the math problem, which was just defined by the critic agent. So that's basically the agent which you provide was prompt where you ask agent to kind of explain what the task is, and you provide one successful example and one unsuccessful example of your agent solving a particular problem. And so here I just picked like 4 criteria in its description and accepted values. So, and it's all the output of the the agent. So nothing of that I came up myself. So I can just, at this point, is like, especially if, like, for example, I design a new application for a new domain, and I have seen, for example, we tried the experiment for the robotic space. So where I'm not an expert. So, and actually, like, the critic agent helped us to figure out like quite a complete set of criteria, which was verified by the domain expert later on. So like that's basically saves us a lot of time on figuring out what are those important criteria which are very important for this domain. So, and again, like, you can do it very easily with just a critic agent, which suggests you this table. It's very important to follow the accepted values as suggested by the critic agents here. So like all this 0, 1s, and 2, that's what we did to kind of clarify it and like use it for the later histograms. But in general, so like you better stick with the language of it. So just if you have, I can go on longer explanations why, but just like believe me, that was the best way to go, to make sure that like you provide for the quantifier agent the textual description of this. So basically that's all comes for free. And by the way, so you would say like, how is it important? That was really important. For example, one of the first criteria which was shown for the math problems was the code quality. And I was like, what kind of code quality? And then I realized that Autogen, so like one of the baselines which we use, produce a Python code to solve these problems. That's why we're kind of achieving very high quality. So very high, so like basically it's doing the tasks right. The question is, if you want to actually solve it, you then provide like writing the code. So for example, if you're trying to do something like a teacher agent, is it that something you want to do or not? Again, it's up to you. It's your application. So we're just here to help you to evaluate and define what the task utility can be. So, and another thing you might ask me is that like the quantifier agent in this case sees unseen examples of your agent and tries to quantify them. So basically, like if you define a new solution or provide a new baseline and you stick with kind of task utility you want to be following this type of criteria. So the quantifier agents can help you to assess the unseen examples and see if like you improving on some of those criteria. So, and we desperately needed here the verifier agent, because the verifier agent can tell you which criteria are good, or maybe like it's better to say which criteria out of what you have is like can be easily assessed by the quantifier agent or not. So, and we specify the verifier agent, which will help you to filter the criteria which are actually stable and robust. And also they are very, so they're supposed to be good with adversarial examples, and I will show you a bit of a example later. So you can download, like here, I think you can download the paper. And by the way, the AgentEval is part of the AutoGen now, so you just go run it. So that's the main part of the talk you may want to remember. So imagine you are designing your LLM-powered application. You use agents which are communicating to each other to solve the task. They produce a lot of logs for you. So, and you can basically, based on these logs, figure it out what kind of criteria are important for your task, and hopefully for your end users as well. You can use a quantifier agents to kind of assess the quality of each of unseen or unseen solutions, and then using the verifier agents, you can just filter the criteria which we think are not really stable. That's possible because there's a lot of things needs to be done still to figure out how well this quantifier agent works. And you can do it for any type of domain, and you don't have to get the ground truths for this. So if you have, that's great. But if you don't, then we'll just want to explore. There's something that you can, in a couple of minutes, set up and get the first idea what's your users can be using it for. So here, just give you also a bit of an example, and let's come back to this idea of like we developing something new. This is a new approach of how you can do the sort of assessment. We call it assessment because it's a bit over stretched, called evaluation, in my opinion. So, but like that's why we split. We start with a task where we can split the successful and unsuccessful tasks. And so here, what you see the same criteria. So it's only for, usually it's up to 25 criteria you can get for majority of tasks. And you could see like 3 baselines. It's like React, Vanilla Service, GPT-4, and AutoGen. And you could see that, for example, for clarity, efficiency, and completeness, you have also in line that successful tasks actually higher on average for each criteria. That's kind of the things we were trying to make sure that we following. So just because, again, we're doing something new, we have to have some kind of ways of verifying if we're doing it right or not. So, but you can see that there's a variation in terms of how the various types of criteria are kind of assessed by different baselines, and that's kind of can be like then up to you to decide if you want to go with one of them. But also important part is like to keep those assessments, and if you change your agents, underlying agents, you can reiterate the process and see, first of all, there's a possibility that your new baseline can bring new criteria into the place, because kind of your solution sometimes brings some of these criteria, and you could see if that's something you want to go with. However, this error analysis doesn't look really good for us. So like that's where we think that quantifier couldn't do a job to assess the proper kind of the proper way of the error analysis, and that's what the verifier is for, because the verifier will tell you that maybe error analysis is a good criteria you want to have, but we just cannot assess it in the current state. So, and that's definitely more research needs to be done towards figuring out if we can do something about it. So, and this is another important part to figure it out, is that there's a task-based criteria and there's solution-based criteria. So sometimes if you just describe to LLM what you want to evaluate based on a task, it can suggest you different criteria, but providing the successful and unsuccessful example can open up the types of, again, like if you just describe to LLM like what's the criteria for solving the math problem, the code efficiency would not be part of it, at least like at the times when we tried it. But since now sometimes we use the code to solve the math problems, that's kind of that's part of it now. So, but it's also kind of important what you could see here, that you at some point kind of that would be suspicious if our critic will give us the more kind of iterations we run, the more criteria is going to suggest. So like it looks like at some point we can plateau a number of criteria, which is a good sign. So like basically there's a limited number of this. And from my own intake here is like I would not worry too much about the accuracy of these criteria. Sometimes people say like, are they going to be correct? It's only like in the worst case 25 criteria, 30 criteria per domain. As a domain expert, you can easily verify some of those, and you can remove the one which you're not interested. I would be more concerned figuring out how complete is this set. And that's research needs to be done on this in this area as well. But another intake here, please try to, as soon as you propose a new solution, rerun your critic. You would be surprised because the critic might discover new criteria which is introduced by your solution. So, and this is another kind of ideas about how can you see this again. We have this advantage here that we had like successful and unsuccessful cases. So, and then just to see the distribution of a quantifier output for successful, you could see that's a dark blue, and failed cases. And for example, again, for error analysis, you could see that basically the scores are kind of almost the same on average. That's not what you want to see. So, but again, we learned it based on the examples, how to, based on examples where we have success criteria, and like using the verifier, you can filter the criteria which are unstable, even if you don't know the success of it. So, and another thing is that like was interesting to do it, figuring out if the sort of worse examples or worse solution is actually shown to be worsened for different criteria. It's not such an easy task because again, we just have here like either successful or not successful solutions. That's why so like you didn't have a gradation. So like as you could see here, this average values, which is corresponded to the categories I showed you in the beginning. So what we did, we just take and introduce the noise in an existing solution. And then the hypothesis was that the samples which would be having containing the noise, so disturbed samples, as we could see here, should get lower score based on quantifier for in comparison to the same examples, but without noise. And so we could see that this is actually the case. So that means that you can sort of trust the idea that quantifier will rank higher the examples which are like sort of a better quality for various types of criteria. Again, this is important because we're trying to set up something absolutely new here. And as a conclusions, so we introduced a novel framework. We called it AgentEval. So it's designed to quickly evaluate LLM-powered agentic application. Here you have a QR code. You can go to the blog post was as part of the AutoGen library and just try AgentEval for your LLM-powered application. Also, actually, that's based on an academic paper which will be presented tomorrow, I think, at the EMNOP as well. So, and we believe that it can be used for any type of agentic applications where you have logs which you can analyze and see how your agent is behaving. And that should be very scalable, and it's cost efficient as well. So you don't really need to run, even do a lot of LLM calls to get your first sense of various types of criteria. And it can give you kind of interesting outline is like what that potential utility can be. So for example, for this mathematical math application, some of the criteria was basically that solution was verbose. And maybe you want verbose solutions, especially if you're designing something like a teacher. So, and the beauty of this is that, like, then having this in place, you can actually keep optimizing your agents for providing the more verbose solutions. Or you can even give it to outsource it to the users and ask them what kind of solutions they want to have, what kind of utility they have. But having those criteria and having a good way of figuring out if it's actually your solution is following those criteria using the quantifier can help you to kind of optimize your application towards the user needs. So, and another thing is that, like, as I said, like, AgentEval helps you to uncover your capabilities and seeing how they evolved over time. Because if you propose a new solution, there's a possibility that that will bring a new criteria for you as well. So keep an eye on that. And we hope that's going to help the developers, all developer community, to figure out how to assess their solution and align them with the needs or with the criteria they want to kind of associate their solutions with. So, and this definitely potentials, a lot of potentials work. This is one of the first directions which we can go. And I'm just super happy was here today to share this work, because I think that's potentially it's can uncover the ways for developers to actually figure out the strengths and weaknesses of the agentic applications based on real data, based on kind of interactions, and just also bring awareness that we need to optimize our applications not only towards the obvious metrics like latency, even success, but also this underlying multidimensional way of how users receive our application, and we have a way to influence that through this. And thank you so much for your attention. That's pretty much completing my talk today.
Awesome. Thank you so much for coming. Fortunately, we don't have time for questions. So, at this time, everyone can mosey on over back to track 1 to view the closing. But really appreciate everyone coming and viewing, and really appreciate your time, Julia. Yeah.
Thank you so much. If you have any questions, please reach out to me. Either and LinkedIn or DM on Twitter is also open. So I'm happy to follow up on any questions regarding this work. And again, it's available as a part of the AutoGen library, and more extensive explanation as a part of the paper. Yeah.
Awesome. Thank you so much. Take care.
Thank you.